To study this system of differential equations numerically, we have to be given some numbers to start with. So if we assume that r of 0 is 12 and f of 0 is 2, then we can use those values to plug in for r and for f into the differential equations, which will give us values for r prime and f prime, how fast the function is changing. Okay, so we'll make a little chart here for t, r, and f that we will use to keep track of what we know so far. Right now, we know that when t is 0, r is 12, and f is 2. Now we can find rates of change by plugging in here. So r prime of 0, when t is 0, we know that r is 12. So 12 minus 12 times 2 would be negative 12, which means that the rabbit population is changing by negative 12 rabbits per time unit. Okay, so we know that at time unit 1, the rabbit population is going to decrease by 12 from what it was at 0, because the rate of change is negative 12 rabbits per time unit. So at time unit 1, we're going to decrease the rabbit population by 12, and now it's 0. Now the rate of change of the fox population at 0 would be negative the number of foxes plus the number of rabbits times the number of foxes. So negative 2 plus 24 is 22 foxes. That's the rate of change. So f prime says that the fox population is increasing by 22 foxes per time unit. So the fox population has gone up. There were 2, it's going up by 22 foxes per unit of time, so now there are 24 at time unit 1. And then we repeat this process to figure out how many rabbits and foxes at time unit 2. So I have to calculate r prime at 1 and r prime at 2. Oops, sorry. I meant to say f prime at 1 to figure out approximate values of the rate of change. Okay, so r prime of 1 would be the rabbit population at time 1, which we know is 0, minus the rabbit population at time 1, which is 0, times the fox population 24, which is 0. And then the fox population at time 1 is negative f, so negative 24, plus r times f, which is r is 0, and f is 24, so we get negative 24. Okay, so my r prime tells me that the rabbit population is not changing. It is changing by 0 rabbits per time unit. So that means that I had 0, and it's changing by 0 per unit of time, so there are still 0, which makes sense. Once you get to 0, that's it. You can't change anymore. And then f prime, it is changing by negative 24 foxes per time unit, decreasing by 24 foxes every unit of time. Right now we have 24, it's decreasing by 24 every unit of time, so now we have 0. And both populations are now extinct. This takes a long time, assuming that the two populations don't go extinct in 2 steps, and a computer program would be really, really helpful to carry out this method.